Hello everyone, welcome back to channel. I am Nikhil Kumar. In the last video, we trained our first machine learning model, saved it, loaded it back and used it to make prediction. But there is a problem. Right now, someone needs to run the Python script manually to use that model. And that's not how real applications work. Applications communicate over network, and that's where API comes in. In today's video, we will take the model we built in previous video and expose it as a real service using FastAPI. By the end of this video, you will be able to send a HTTP request to your machine learning model and get a prediction back. So let's get started. Before we jump into today's video, let's do a quick recap what we built in the previous one. We started with a dataset which contained the historical data used to teach our machine learning model. Then we passed that dataset into the training process. During training, the machine learning algorithm learned the patterns from the data and built the predictive models. And once the training was complete, it produced a model artifact called model.pkl. And this file contains everything the model learned during the training. But right now, there is one limitation. The only way to use this model is by running a Python script manually. In today's video, we are going to solve that problem by placing a FastAPI application in front of our model. Instead of executing Python scripts directly, any application can send a HTTP request to our API. The API will load the trained model, generate a prediction and send the response back. And this is the first step towards turning our machine learning model into a production-ready application. So let's build it. So I am continuing with the exact same project from the previous video. So I am going to use the same dataset, same trained model and same environment. We have simply extended what we have built already. So before we build the API, we need two packages, FastAPI and Uvicorn. So FastAPI is the framework we will use to define our API and Uvicorn is the web server that will actually run it. So first of all, let's activate the Python virtual environment which we have created in our previous video. So source venv bin activate and install the two packages, that is pip install FastAPI and the Uvicorn. So both the packages has been installed successfully. So here the FastAPI defines the application and Uvicorn serves the application. So now that our dependencies are ready, let's build the API. So we are going to continue with the same project from the previous video. We already have our trained model, that is model.pkl. Now we are going to create one new file, that is app.py, and this file will become the entry point for our API. And instead of building it line by line and changing it later, let's look at the complete application first. So I have already created app.py and uploaded on the GitHub. So this is the complete API we are going to build in this video. So now let's understand what each part is doing. So first of all, I am importing the libraries. So first we are importing the FastAPI. So this gives us the framework we need to create our API. Next we are importing the base model from the Pydantic. We will use this to define and validate the data our API receives. And finally, we are importing the Joblib. We used Joblib in the previous video to save our trained model. Now we are going to use it to load that model back into the memory. Next, we are creating our FastAPI application. Think of this as the main object that will hold all of our API endpoints or route. Everything we are going to expose through HTTP will attach to this application only. And now comes the most important part for our machine learning application. We are loading the trained model we created in the previous video. And remember, model.pkl is our trained model artifact. We are not training the model again. We are simply loading the already trained model into the memory. And this is what an inference service needs to do. So the training has already happened. Now we are ready to use that model to make prediction. Next, we need to define what data our API expects from the user. Our machine learning model was trained using 4 flower measurements. So we are defining those 4 fields here. And we are saying that each value should be a number, specifically a float. And this is where Pydantic comes in. It validates the incoming request against this structure. So instead of accepting random data, we are defining a clear context for our API. And after that, I am creating our first endpoint. And this is the get endpoint at /. So whenever somebody sends a get request to the root URL, FastAPI execute this function. And here we are simply returning a message that is MLAPI running. This gives us a simple way to check whether our API is alive or not. And after that, we have defined our second endpoint, that is /predict. Now we get to the most important part, our prediction endpoint. This time we are using a post request. Why post? Because unlike our health check, we need to send data to the server. The incoming data is represented by our flower model. So when a request comes in, a FastAPI will validate that data before passing it to our function. And after that, we take those 4 values from the request and put them into the format expected by our machine learning model. And remember, our model expects the feature in this order, that is sepal length, sepal width, petal length, and petal width. And now we actually run the machine learning model. This is the inference. The model receives the input, processes it, and returns the prediction. And notice that there is no training happening here. Training happened in the previous video. This API is purely serving the prediction. And finally, we return the prediction as JSON. So the complete flow inside this endpoint is very simple. A request comes in, we extract the input, the model performs inference, and we send the prediction back. And that's essentially what our machine learning API does. So now that we have a complete API code, but there's one important question. Does it actually work? So let's turn this Python application into a running web service. So let's get back to our terminal. So let me clear out the screen first. So here we are going to use a Uvicorn to start our application. And here I am specifying the app, that is our Python file. And the second app is the FastAPI application object we created. And here we are listening on port 8000. And ---- reloads automatically reloads the application whenever we make changes during development. So let's hit enter here. So here we can see our application is running and the startup has been completed. So now let's test it. So for that we can duplicate the session. So here I'm just going to do a simple curl to our local host. So curl http localhost and port 8000. And there we go. Our API is responding. So we have just turned the Python application into a running HTTP service. So now we have accessed the API from the same machine where it's running. But APIs are designed to communicate over a network. So let's see what happens when we access the same service through VM's IP. So let me get the IP. So hostname -i. So this is the IP. So let's go to the browser and here let's enter the IP address and the port, that is 8000. So now we can see that our application is working on the browser as well. And that's exactly how our other application can communicate with our machine learning model. So health endpoint works, but we are not building a machine learning API just to return ML API is running. The real goal is to serve the prediction. So now let's send some actual data to our predict endpoint. So let's get back to our terminal. So now let's do a post request to our /predict endpoint. So this is the curl command I'm going to use. And here I'm using the post request method. And this is the API endpoint for our application. And if you notice, I am specifying the /predict at the end. And here I am specifying the different parameters for our flower prediction. So here I am providing the sepal length, sepal width, petal length, and the petal width. So let's hit enter here. So and there is our prediction. Notice what just happened. We sent an HTTP request. FastAPI received the data. Pydantic validated the input. Our model performed the inference and the API returned the prediction. And that's a complete request to prediction flow. So now let's change the input. So I'm going to use this curl command. So here I have changed the sepal length and all the other parameters as well. But we are using the same API and same model. But this time the input is different. So let's hit enter here. So now we get a different prediction. And this is exactly what we wanted. Our API is no longer hard-coded. It's now accepting real input dynamically. And there is one more thing I want to show you. We have been testing this API from terminal using curl. But imagine having to remember every endpoint, every field, and every request format. That wouldn't be very convenient. And this is where FastAPI comes up with another nice feature. So let's go to the browser. So here in the endpoint, if I add /docs, so it will show us the documentation. So FastAPI automatically generates interactive API documentation for us. We didn't manually create this page, it generated directly from our Python code. So if you notice, we have two default endpoints. So first one is our get endpoint and the second is our post/predict endpoint. And we can open the prediction endpoint here. So if I click try it out, so here we can enter the parameters like 4.8, 0.6, 1.0 and 2.0. And if I click on execute, it gave us a curl command for the same and it executed the same at the backend. And this is the response we got from the server. So we now have not only running a machine learning API, but also an interactive documentation for it. So now we have a working machine learning API, but this is just one model. Imagine tomorrow if we train a new version, then another and another. Now we have a multiple models, different versions and different models. So what model is actually running? Which data is trained on? And if something breaks, what's changed? And this is where things start getting messy. And this is exactly what we will explore in the next video. When models start piling up, how do we track them? How do we reproduce them? And when something breaks, how do we debug it? And this is where chaos begins. If you found this video helpful, hit like share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.